Hello everyone! In this video I would like to show you how to create this animation with hexagonal curves. But before doing that, first we need to talk about the polar coordinate system. We know that any point A in the plane can be represented with coordinates x and y. X is the value corresponding to the horizontal axis and y is the one corresponding to the vertical axis. This is the famous Cartesian system. Another way to represent points in the plane is using the polar coordinate system. The same point A, for example, can be written as r semicolon theta, where r is the distance from the origin to the point and theta is the counterclockwise angle that is made with the point A, the origin, and the x-axis. And to convert back and forth between polar and rectangular coordinates, we can use the following formulas. So for the case of the point written in Cartesian form 1, 2, we have that x is equal to 1 and y is equal to 2. Then using the formula r squared equal to x squared plus y squared, we substitute the values x and y and simplify to obtain r equal to the square root of 5. Now since tangent of theta is equal to y over x, then theta must be equal to the arctangent of 2. Therefore, the point 1, 2 is equal to the polar form the square root of 5 semicolon arctangent of 2. Now if we have the point 4 semicolon pi over 4 represented in polar coordinates, we have that r is equal to 4 and theta is equal to pi over 4. Then using the formula x equal to r cosine theta, substituting the values and simplifying, we obtain x equal to 2 times the square root of 2. In a similar way, we obtain the value of y also to be equal to 2 times the square root of 2. Therefore, 4 semicolon pi over 4 is equal to the Cartesian point 2 times the square root of 2, 2 times the square root of 2. With this in mind, we can represent equations written either in Cartesian or polar form. We just need to use these formulas. They both will represent the same curve. And by the way, in the polar equation, we must define the interval where theta is defined. Like in this case, we have that theta is between 0 and 2 pi. There is a great variety of amazing curves that we can explore using polar coordinates. But the one we are interested in today is the hexagonal curve. This curve is defined with the following polar equation. Here n is equal to 50, k is equal to 2.5, and m is equal to 3. Also the value of theta is between 0 and 2 pi. This is the equation that we need to plot the curves that I showed you at the beginning of this video. In fact, we just need half of the curve, so we can define theta between 0 and pi. Now, since we want this curve to be rotating around the origin, we need to introduce a parameter in the interval where theta is defined. So we add the parameter t at the beginning and at the end, increasing from 0 to 2 pi at a constant rate. This is essentially what we need to plot the hexagonal curves. Now we can explore this dynamically using GeoGebra, and to do so, we need to translate these expressions into GeoGebra code. The three parameters are easy, we just need to type the same values. Now since we want to animate the curve, we need to define the slider t from 0 to 2 pi with an increment of 0.01. The polar curve then is defined with the curve command. In the curve command, we need to input the expression, in this case the polar equation, and also the initial value and the end value. We can improve this code by defining the function f of x equal to this expression and using it within the curve command. So here I'm going to show you how to create the hexagonal curves using GeoGebra Classic 5, but you can also use GeoGebra version 6. Now to start, we need to introduce the parameters that will be n equal to 50, k equal to 2.5, and m equal to 3. Now we need to introduce the slider, which is going to be defined from 0 to 2 pi with an increment of 0.01. The function f of x, we introduce the expression as we defined it before. That will be like this. And then we don't need this function at the moment, so we can hide it, and so we can introduce the curve command. With the curve command, we type a curve and then we select the first option, and we are going to have two expressions here. So the two expressions are going to be the first component and the second component of my polar form. So the first component is 1 over f evaluated at theta, then we type semicolon theta. That is the two expressions, so that's why we don't need this second expression here. The parameter is going to be theta, and the start value 0, and the end value 2, 5. And that is not the curve that we were looking for, and the reason is because probably I made a mistake here. So yes, instead of m here, it should be n. We change that and then we hit OK. So there we have it. We obtain our hexagonal curve. Now we need to change the start value and end value to t comma pi plus t. So we just have half of the curve, and when we drag the slider, we can see that it is rotating around the origin as we want it. So this construction looks pretty cool already, but we can make it better by introducing a few extra hexagonal curves. In order to do that, we are going to copy the curve command with the expression that defines the hexagonal curve, and we are going to use the sequence command with expression variable start value and end value. In the expression, we introduce the curve command with the curve as 1 over f evaluated at theta, and we introduce the j as a variable. So in the sequence command, we use that j as a variable. The start value is going to be 1, end value 10, and there we have it. We obtain a sequence of hexagonal curves. Something that you notice is that if we drag the slider, they all rotate at the same time, and we can fix it by just introducing the j variable in the start value and at the end variable multiplied by the parameter t, that is the slider, and we obtain our animation of hexagonal curves that I showed you at the beginning. And there we have it. We just made a beautiful animation with hexagonal curves. Of course, there are more mathematical properties that you can explore with GeoGebra. For example, try to explore what happens when you try to change the values of the parameters. By the way, for this animation, I used GeoGebra because it is very easy to explore polar curves with this software. However, you can try to make your own version using any other mathematical program or programming language. Try, for example, Desmos or P5.js. The possibilities are endless. Okay, that's it. I hope you liked this video. If you like it, please consider becoming a member in my Patreon, where you can have access to other cool learning resources or mathematical animations that I make with GeoGebra and other programming languages. You can also find out more about all the projects that I am currently working on. Thanks for watching. See you next time.